Okay, see what we got here. This is gonna be easy. Should be nice to extend my streak. Maybe I'll actually get to a month streak, please, given that I've solved a few hards. Alright, count odd numbers in an interval range. Given two non-negative integers low and high, return the count of odd numbers between low and high. Alright. So it's just a count deal. Given a range, I think we can obviously you could use a for loop to go over all the values in that range and then use an if statement to determine if a value is odd, and if it is, increment the counter for the answer, return that counter. But the better way would be to determine just the difference between high and low. That gives you kind of a rough estimate of how many values there are. Roughly half of that would be odd, right? But it's not going to always be half that would be odd. And you just need to consider the cases, the edge cases, or the edge values, the low and high value, whether or not they're odd, and determine it from there. So let's go ahead and just, if you just explore, like there's 4 possibilities of where the low and high values are, where that low and high values are both odd, even, one odd, one even, then that should encapsulate basically every scenario and base it on that. So consider parity, the oddness of low and high values. Okay, so if they're, let's say, 2 to 10, actually we can keep it simple, 2 to 4, 2 to 10. So there's going to be 10 minus 2 plus 1 is going to be 8, 9 values. Generally, if you were to take a range where the low and high values are included, you're going to do the difference and then plus 1. So 9 values. Obviously, because the low and high values are both even, you'd expect that half of this plus 1, or rounded up, is going to be even. So 5 evens, 1 odd, or 4 odds. If this was 2 to 11, just modifying it up 1, that'd be 10 values. 11 minus 2 is 9 plus 1 is 10. And here this is 5 evens, 5 odds. So you expect similarly if this was 1 to 10, 10 values, 5 evens, 5 odds. And then if the thing was odd and odd, let's say 1 to 11, 11 values, this would be 6, 5 even, 6 odds. So basically it looks like in general, if both values are odd, both the n values are odd, then you'd have the round up of the half of the values, the count of half the values to be odd. If it's an even number of things, then it has to be an even number, or has to be an even split of odds and evens. Yeah, okay. So let's say count of the number of things is going to be high minus low plus 1. If this count is an even count, so divide by 2 has a remainder of 0. Return half the count. Otherwise, return half the count plus 1. I guess it automatically rounds down if it's an odd count. If both the top and bottom are odd. I'm gonna get tricky with this. If I do count mod 2, that gives me a remainder and the remainder of an odd number is going to be 1. If I do that remainder, the remainder of the high value and the remainder of the low value, if they're both going to be 1, so I multiply them together, that's going to be equal 1 only if they're both odd. So actually, okay, so the kind of straightforward way of doing this would be if high is odd, high mod 2 equals 1, and low is odd, low mod 2 equals 1. Return count divided by 2 plus 1. Else return count divided by 2. So this should work for most things, but actually, so this would be the most simplified version, I think. This is most simplified version I can think of. It'd be something like return high mod 2. Actually, I still need to have count. Return count divided by 2 plus the product of high mod 2 times low mod 2. Because this is going to only be 1 additional if both the high value and the low value is good. They're all going to end up being the same speed, I think. They're all just very fast. So it doesn't really matter, but it's kind of a neat trick to what the heck? Okay. I think it's just the count deal. High minus low plus 1. Can't imagine this being it has to be faster. 38 milliseconds. Wow, what the heck? How can I go faster than this? High mod 2, low mod 2. Learn the count of numbers between low and high. You have two odd numbers. They could have the same average as two even numbers. 111 is 5.5. No, 111 is 6. You have 210 is 6 average. So the average doesn't necessarily indicate anything. If both the top and bottom are odd, then I mean high and odd 2 is going to calculate to the same as the parity. What was the thing here? 46 is going to be even slower. Yeah, I mean, hmm. Do. I wonder if you just check the parity of the bottom one. We always do the round down. We always do the round down of half. I wonder if just no. Yes. Mm. Oh, you need to have both. You have both the odd. What if you just did high minus low divided by 2, instead of high minus low plus 1 divided by 2? So high minus low here would be 8 divided by 2 would be 4. So you have 4. So it's 8, 4. So the round down version is going to be 4 and 5. So here it's going to be 6. Round down version would be 5. 11, 10. 10 divided by 2 is 5. Which means 1, 5, 1, 6. So high minus low plus 1. High minus low just divided by 2 would give you the less common one. Less common one being either odd or even. The less common one being odd or even. And I guess you could use the parity of the lower value at that point. That would work. Or the opposite of the parity of the lower value one. Or use the parity of the higher one. The parity of the higher one to increase it. So something like we'll turn high minus low divided by 2. No, you don't necessarily need to increase the parity here. It would be 10 to 5. Yeah, you don't need to increase the parity. You don't need. Yeah, you can't just use the parity of the higher one to increase it because it's not meant to increase here. There must be some sort of trick I'm missing there. Like this seems as simple as they're gonna make it. 51 seconds. How do you slide? Right, I'm going to try just one last time to verify that this is in fact all random. Okay. Okay, I don't know. Okay. I'll keep the other one. logic. Okay. I don't know. I'll just say, not sure how you get faster computation than above. But I mean, obviously you can. Maybe it's random. It's beyond my knowledge. But for simplified logic, consider the four scenarios for parity of low and high values and how it affects the calculation of odds versus evens in general. Half the values are odd and half are even. So the key is to figure out whether it's half plus 1 or not, just basically, because half is going to be the average, or half is going to be like 5.5 if the number of values is an odd number. Like if there's 11 values, there's going to be 5 odds, or 5 numbers that are one parity, 6 numbers that are another, half being the rounded down version of the average. Look at the above example. The fast, or the one-liner, I'll just say the one-line solution or expression to return the count up odds just uses the parity of both high and low to convert to the plus 1 value. So high mod 2 is going to give you 1, low mod 2 is going to give you 1 if both the high and low values are odd. That multiplies to get 1. If it's any other combination like 0, 1, 1, 0, 0, 0, then to multiply is 0. So it's not going to give you plus 1. And based on this here, the only time when you want plus 1 over the half rounded down version is going to be when both the high and low values are odd. So it's just kind of an AND logic right here. Alright, time complexity, this can be O1 since it's just a constant calculation. And space complexity, this will be O1 since no space is needed. If you kind of do it with a for loop, then obviously time complexity would be O of n if you iterate over the n values in the range. Alright, cool beans.